What are things we saw in the work? What is work done? First we saw. What is work done?
When a force is applied and the object is displaced.
Displaced. And what's the formula for work done? Force into displacement. Right?
Yes.
Okay. And what is the normal force we saw?
Force which is perpendicular to the object.
Object. And gravitational force?
Force which is perpendicular to the ground.
Ground or gravity or surface of Earth. Okay. Can work done be positive or negative?
Yes, sir.
Yes, sir.
When can be happening this thing?
It can be negative due to frictional force.
Negative due to friction force, or when force is negative, then work done is also negative. And any other case?
So when force is negative, it will be negative, or when displacement is negative, it can be negative.
Yeah. And SI unit of work done?
Joules, sir.
Joules. Right. In CGS unit of work done? Yes. No idea?
Forgot.
Forgot? What did we write? Yeah. Okay. So with that, let's do some numericals. Just a minute, let me connect my pad. Okay, I'm back. Okay, this question looks good. Let's try this. You can all try with me.
Okay, sir.
I think so. Second question, right?
Yes, sir.
A block of mass 2 kg is pushed 2 meter along a frictionless surface. Frictionless horizontal table. By a constant force 15 Newton. Okay. Newton. What is work done by number one, applied force. Force which is applied. Second one, let's try this also.
Sir,
Yeah,
is it for 30 the work done? 30 joules.
for first one or second one,
First one.
it should be 30 only. 15 to the 30, right?
Yes.
Force into displacement.
Yes.
Now, force of gravity. Two ways I'm asking here. First is work done by applied force. What is applied force? This one. 15 Newton is our applied force. I've given a little bit extension to the question. That is force of gravity. Work done by the force of gravity.
Is it 0 because there's no change in height?
Yes. There is no movement. It should be 0. When there will be a force due to gravity, when there is upward movement or downward movement,
Yes.
right? Yeah, it's just moving here on the constant force. Sorry, by the constant force. So work done equals to force into displacement, which is 15 into 2, which is 30. What's the unit? Yes, 15 joule. That is what first part says. And second part, as there is no motion downward or upwards, therefore work done equals to 0. So you can write the reason. There is no upward or downward motion. Got it?
Yes, sir.
Let's do one more question. This work done questions are very easy, right? Just directly just multiply, that's it. Nothing else.
Yes, sir.
Yes, sir.
Okay, so let's do one more, then we'll move with next topic. Did he pulls a vacuum cleaner? So the force of magnitude 75 Newton. The force makes, okay, no, we don't want angle here. You haven't studied angles here, right? Okay, let's change a little bit. in the vacuum cleaner is displaced 5 meter in direction of the force. Calculate work done. Come on, get me answer.
It's 75 times 5.
Yeah. How much is it?
Right, I'll just calculate it.
Yeah, sure.
375.
375.
375.
Yes, sir.
Okay. Is the same everyone is getting?
Yes, even I got 375.
Okay.
Sir, will it be minus?
Why is it so?
Okay, I thought.
No, like, why you're saying that?
Because I thought it's getting displaced in the direction of the force.
In the direction of force means it will be positive. If it is against the direction,
Oh yes, sir, I got confused.
okay, if it is against the direction of force, it will be negative. In short, like, what is this positive and negative? Whatever we are getting, force is forward direction. Suppose it's going on right, and we are getting displacement. We are applying force on the right direction, and we are getting displacement on the left direction. In short, opposite to that. That's why we will assume that as a this side is positive and one side as a negative. If both are on same direction, that will be positive,
Okay, sir.
right? Okay. So is there anyone like want me to solve here, or shall I go for next?
Next one, sir.
Next one. Okay. Just I'll write this formula. Force into displacement 75 into 5, which is what's the answer you said? 30.
375.
Okay. Joule. Fine. Okay. So we saw here work done. Now let's see energy. What is energy?
Energy is required to do work.
Yes, energy requires to do work. Or
Capacity of doing work.
yes, capacity to do work. Yes. Anything else? Come on, it can be so many things. You can say so many things about energy. Yes, come
It
on.
is divided into kinetic energy and potential energy.
Yes, it is like there are so many types of energy which in that kinetic energy and potential energy. But what is the type? Like kinetic and potential, we said, okay. It's actually mechanical energy. So we can say like there are some types of energy. What are they? Heat energy, mechanical energy, what else? Chemical energy, right? Light energy, which its source. Chemical, light. We are just going to concentrate about this two. Heat will study separate chapter. Chemical, light will study separate chapter. But right now we are going to study about mechanical. That is like the kinetic and potential. Kinetic energy and potential energy. Now, as you said, what is energy?
Capacity to do work.
Yes, capacity to do work. Now, what was work?
The displacement of object when Force is applied.
Yes, displacement of object when force is applied. Now, how much, like, what is the capacity of something to displace that object? Right, that will tell energy. Okay, and the next is power. What is power? Rate of doing that work. So at what rate we are doing that work, that will be defined by power. How much capacity we have to do that work, that is defined by energy. It will be defined by energy. Okay, so capacity to do work. So now let's see about kinetic and potential energy. Kinetic energy. What is kinetic energy?
The energy due to the motion of an object.
Yes. Due to motion of an object. And then potential energy?
Energy when the object is at rest.
Yes, when object
Due to
at
the
rest-
position of the object.
at rest, yeah, due to the position of the object. Okay, so like same way, if object is moving, I'm throwing a ball. Okay, I'm throwing a ball. At this point, it acquires potential energy. It is having potential energy. Now, once it starts moving down, this potential energy will be converted to kinetic energy. In nothing, these both are nothing actually. It's just description of energy. At this point, it will be this energy. At that point, it will be this energy. That's it. There's nothing big here. So we have just divided into two forms. One is potential, which is stored, and one is kinetic, which is in motion. Simple words. So like stored energy, let me write here. So let's write some points about kinetic energy first. Then energy of a body due to its motion. That is kinetic energy. Okay, give me some example of kinetic energy. I want from each of you, one example from each of you.
So
roller coaster.
Roller
A
coaster.
ball falling to the ground.
Okay, ball falling to the ground, roller coaster.
Sir, roller
flower pot.
coaster.
Yeah, roller coaster. Okay, next.
A flower pot balanced on a wall.
I'm sorry, say again.
A flower pot balanced on a wall.
Okay, flower pot balance on the wall. It's kinetic energy. Okay,
So isn't that potential energy?
that is potential energy. But I'm asking example for kinetic energy.
So when a bus
Bungee jumping.
Yeah, bungee jumping. Anything, you're running, you're throwing stone, moving car. What else you see? Like wind, flowing wind, right? All those are like example of kinetic energy. Even like firing bullet. Bullet has kinetic energy. That's why it's moving. So whatever
Yes,
moves, it has kinetic energy. Okay, so let's derive that kinetic energy formula. So example, you can write two examples. You can write up to you, whatever example you want. Okay, we saw work done equals to force into displacement. Now, what is force? Mass into acceleration. Now, what are three like laws of motion? Three equation of motion. First one,
Sir, v square minus u square equals to as.
Okay, next.
S is equal to ut plus half ap square.
Yes, next.
Sir, v equals u plus at.
This is first equation motion, second equation of motion, third equation of motion. Right. So find out S from third equation of motion. Then we'll substitute in this equation. Let's do that. I hope you have derived this one in your school or like any other class, right?
Yeah,
Yes,
sir.
sir.
Very good.
Yes, sir.
Then let's see. What is the first step? What you will do here? Find S equals to p square minus u square by 2a. So we can substitute this one in this equation. Force into what? Substitute their value.
Displacement.
Even I can, instead of force, I can directly write ma. M into a into v square minus u square by 2a. A can be cancelled. So m into v square minus u square. So this is what work done in form of kinetic energy. Work done and energy both are same at some cases, but it is in form of kinetic energy here, and there it will be form of potential energy. Potential energy. So half m v square minus u square. Now, if it is starting from rest, that point u will be 0, right? Done?
Yeah, sir.
Okay. What about others?
Yes, sir.
Yes, sir.
Super. So I'm just keeping it this way itself. I'm not like making it other
Yes, sir.
form, that is u equals to 0, that you know already. Okay. So can you derive this for potential energy? Same thing for potential energy.
Yes.
Okay, sir.
Okay, do it. After you get this potential energy, we'll compare. That's why I'm asking you to do it. So m
Done, sir.
g h. It's very easy, right? Force into displacement.
Yes, sir.
Yes, sir.
Okay. Done? Okay, let's compare this. Now, like, can you give me one example for potential energy?
A stone is placed.
Stone is placed. Okay. Something is placed somewhere at some height. Okay. Fine. So what about like we can say potential energy is directly proportional to mass. From this one we can assume that potential energy is directly proportional to mass.
Yes,
So
sir.
higher the mass, higher its potential. And similar way, reverse. Or we can say vice versa.
Yes, sir.
Lower the mass, lower the potential energy. Now it is also depending on height. Depending on height, but what path it follows, does it depend? Like if it is going this way, or it is going this way. So it does not depend upon like what path is following, A or B. It just at what height it is. Right? We can say at what height it is. So it's directly proportional to height. It is not depending upon any path. Whatever path it follows doesn't matter. So it does not depend upon path. Let's write that. Okay, no problem.
So what are we doing?
We are just doing some numerical and we are deriving some potential energy and kinetic energy. Derive this
Okay,
one.
sir. Are we doing structure of atom?
No,
Oh, okay. Oh, okay.
it's physics class.
Okay, sir.
Yeah, it does not depend upon what I was saying. Yeah, path. Path it follows. Okay. So what else we can say? Anything else we can add in this one? You want to add anything? Yes, guys.
No, sir.
I think that's it. Or shall we add something? Okay, let's think. Yeah, what happened when it change of shape or shape is changed? What happened then? We saw mass, we saw height. Okay, change of shape. What happened when it is change of shape? So can you guess something? What will happen if there is a change in shape?
If it's a spherical kind of shape, the frictional force will be lesser.
Okay. So work done will be reduced. That's what you're saying?
Yes, sir.
Okay. Now, if it is stretch or if it is like let's take example of balloon. Yeah.
Yes, sir.
So if I'm stretching it, like if I'm stretching that balloon or something, I'm twisting the rubber or bending the rubber, eraser. So it is having like more potential. Those things which can be like change shape, like it is having more potential energy. So let's make a point. Higher the stretch means, let's write this way, greater the stretching, or like twisting, or bending, more is the potential energy. So as we said here, does not follow path. Suppose if I say like a object is lifted here from here to here. And it follows this way, and object is lifted here to here, but follows this path. So what would be the difference?
Nothing, sir.
Thanks, sir.
It won't be a difference.
No difference, sir.
The height is same.
Yeah. So height will be same. So that will be, that's why we said here, we gave one conclusion that it does not depend upon path, it just depends upon whatever height we are using. Okay. What happened? You all are a little bit dull, tired or what?
No, sir.
No, sir.
Okay, okay. Then let's do some numerical with this.
Okay, sir.
Okay, sir.
Okay, sir.
Let's start with some easy question. As usual, like a standard question you will find in every book. If a body of mass 10 kg is raised to a height of 6 meters. Above the earth. Calculate its potential energy. Someone tell me this answer. The next we can do some NTSC question. Let me get some NTSC question.
Sir, what should we take the value of G?
G, you can take 9.8.
9.8. Okay, sir.
So is it 588?
It's 588? Yeah. 9.8 into 6 into 10. Yes, what about this? Yeah. I'm waiting for the answer. What about this?
Sir, is it 588?
All of you are getting same? 10 into
Yes, sir.
9.8 into 6, which is 588 joules. Okay.
Sir?
Yeah.
Sir, it should be minus 588, right? Because it is above the Earth's surface, so
Okay, raised above. right?
Yeah.
So if
Yeah.
a body of a mass 10 kg is raised to the height of this much, so against the gravity we are going, right? And towards the gravity. So if we are taking against the gravity as negative, then yes, it is negative above the Earth's surface, raised above the Earth's surface. And if
Yeah.
this object is coming towards the gravity, it will be plus.
Yeah, sir.
Right? So there is a question I'll just ask you orally. It was in SET exam. So it's very easy. Like work done by frictional force is like designated as option A infinity, option B 0, option C is positive, option D negative.
Negative.
Repeat.
The work done by frictional force is designated as option A infinity, option B 0, option C positive, option D negative.
Sir, it's negative.
Negative, sir.
Yeah, it
Negative.
should be negative. Okay, next question is like kinetic energy of object is proportional to option A velocity, its weight, B option C momentum, option D square of its velocity.
Square of its velocity.
Square of its velocity, right? Because we are writing half mv square.
Okay,
Okay.
sir.
Yeah, try this question. I find this question good. Let's see. Not good, it's easy only. Velocity. Yeah, you can do it. This was asking some SET exam. You know SET exams, right?
Yes, sir.
Yes, sir.
So is there anyone preparing for that? After 10th,
Yes,
you're doing
sir.
12th, right? Okay. Even these questions are easy up to 10th standard, all questions will be easier, but then it will be a little bit difficult. Same topic you will study in 11th standard. I'm teaching, no, I didn't, they already finished, but same topic. And I gave a question, above question, right? This question is from 11th standard book actually. It's easy only, direct questions. First, like initial questions. Then we can have some angles and all. That will be different then. Whenever you study 10th, it will be studied by 10th standard mathematics. Okay. So kinetic energy of an object of mass 1 kg is 200 joules. The velocity of this object is, so I'll give you option later. First you get the answer. Yes. I'll give you 30 seconds. Come on, finish it.
The 400.
400,
Is it 200?
200. Okay. I got 400, 200. Then
Sir, is it 20?
20. Okay, somebody is texting. Yeah, 500. Okay. 400, 200, 20, 500. I want unanimous answer. I'm getting so many options. You know, whatever answer you said, this answer, none of your answer are in option. No, one answer is there in option. Sorry, yeah. 20 is there in option. Okay. Shall I give you option or you want to try once more?
I want to try.
Yeah, sure. Try it. Know the formula, right?
Yes, sir.
Great. Oh yeah, somebody's texting. 20. Okay. Okay, yes, time's up. Option A, 200 meter per second. Option B, 10 meter per second. Option, where is C? C, 20 meter per second. Option D, 40 meter per second.
Sir, it's option C, 20 meter per second.
Yeah, sir, it's option C.
Are you sure of it?
Yes, sir.
Yeah, sir.
Even there is no answer here, I have to calculate. But even yes, option C is correct. This is just question here. No
Sir,
answer.
because half into 1 into
Yes.
V square is equal to 200,
200
MD square is equal to 400. 400. V square is equal to root 400, which is 20.
20 meter per second.
Oh, I missed the last step.
No problem.
I also missed the last one, sir. The calculation of 20 meter per second.
Oh yeah, you just forgot the square, right?
Yeah, sir.
Okay, no problem. Okay, do you know conversion of meter per second to kilometer per hour?
Yes, sir. Into 5 by 80.
Yeah. Into 5 by 80, yeah. Okay, this question is good. 2 meter and hits the ground. Yeah, you can do it. Super. So even I have to calculate because there are no answer in this one. Only questions. So question number whatever. A tennis ball. From a height. See, I'm just giving you all mixed question like from work, from energy, because you already studied this one, right? So I'm just giving you as much as questions possible.
Okay, sir.
Okay, sir.
Of because you already studied theory, so it's no use of teaching a theory again and again. And the bounds only 1.5 meter. Nice. A tennis ball drop from a height of 2 meter, rebounds only 1.5 meter after hitting ground. What fraction of energy is lost in impact. What fraction of energy is lost in impact? So you understood the question?
Yes.
Okay, try it.
Sir, so we should give answer in fraction.
Yes, it should be in fraction or in ratio form.
So is it 0.5 by 2?
0.5 by 2. Zero 0.5 by 2. Okay. Someone writing 1 by 4. Okay. In short, instead of 0.5 by 2, we can write 1 by 4.
Yes, sir. I got 1/4.
1 by 4.
Yes, sir. I have sent in chart.
Anyone else? Any other answer? Okay. Any other answer? Or same 1 by 4. It doesn't matter it's right or wrong. You should get your answer. Okay, shall I give you option? Option A. Sorry, wonderful. Yeah. 1 by 4. Option B, 1 by 8. Option C, half. Option D, 1 by 16.
1 by 4.
Okay, option is for you, option A, fine. Any other option? What about others? Vivek, Satvik, Ritvik,
Yes, sir.
Sir, 1 by 4.
Same, sir. 1 by 4.
is there anyone who is going down in solving this? See, don't feel shy because we are studying here. Is there anyone who's having doubt in this calculation or something?
No, sir, no doubt.
No?
No doubt, sir.
Sir, can you keep a quiz on this?
Sorry? Can I?
Sir, can you keep a quiz on this?
Yeah. Yeah. Okay, one more type we can do. Yes. This question will take time to write also. You know how to read graph, right?
Yes, sir.
Okay, then let me draw a graph here. Then fast I'll draw here because this drawing will take time. This is force. This is x in this in centimeter. This force is in dynes. Oh, it is in dynes. Nice. Then 1 to 8. 1, 2, 3, 4, 5, 6, 7, 8. Then here plus and positive and negative. 10, 20. Minus 10 and minus 20. You draw it straight. Then it goes to 20 and positive 10 and negative. Go to 5, 10. Okay, so here is the question. You draw, then till then I will write the question here. The relationship between force and position is shown in figure. So work done by the force is displacing from x equals to 1 centimeter to x equals to 5 centimeter is how much? Option A, 700 ergs. Option B, 70 erg. Option C, 60 ergs. And option D, 20 erg. This looks complicated, but it's very easy, right? What happened? Slept or what?
No, sir.
No, sir, thinking.
That's a thinking. Okay. Yeah, good. Good to think. I thought by seeing this big question, you slept. Dynes. So it is going. So how it is going? Oh, I can't hear you. I'm not saying anything. I'm just waiting for your. So what is happening here? See, just easy way, follow the path. It starts from 1, right? 1, then like from x-axis 1, then y-axis to 10. It's following this one. Let me use another color. See this path, right?
Yes, sir.
In this path, it's going negative here, here, here. This. See the path. You'll get answer. Okay. Let me give you a hint. I guess you're facing difficulty. Let me give you a hint. To find this, to find work done here, where is my marker? Oh. We need to find area under the curve. So length into breadth, length into breadth. Simple.
I didn't get it, sir.
So area under the curve will give you work done. For this one, what is this? Force into displacement will give you work done. This is displacement. This side is work done. So hint is find area under curve. Then you try this again. Area under curve or graph will give you work done.
So can you scroll up?
Oh yeah, sorry. Till 5 only we have to do. Do you all have class at 7:30?
Yes, sir.
Oh, then we can do one thing, take this as a homework. Try this. Use the hint which is given. Try this.
Okay, sir.
Okay, sir.
Yeah, because again you have to log out and log in. It will take time. Yeah. And see you next class. Try this question with the hint.
Yes, sir.
Shall I stop sharing?
Okay, sir.
Okay, sir.
Okay. See you. Bye-bye, everyone.
Bye, sir. Thank you.
Bye, sir. Thank you, sir.
Bye-bye.